Okay, let's go ahead and get started with section 2.2. So yesterday we talked about shapes that were congruent. And so really for the next 3 lessons, we're going to talk about different transformations, 3 different types of transformations that result in congruent shapes, meaning we're not actually changing the size or the shape of our figure. So a transformation changes a figure into another figure. The new figure is called the image of the original. So the new figure is called the image. A congruent transformation moves a figure. I had to think about that word for a second. Okay, it moves it. It's going to move it. And so I say move because it's not changing its shape or size. So the only thing you can do is change its position then on the coordinate plane. And so there's 3 different ways that you can move without changing shape or size. And so the 3 transformations we're going to talk about today, we're going to talk about translations. A translation is going to slide a figure around the coordinate plane. Tomorrow we'll talk about reflections, which will flip the figure over a line. And then on Monday, we'll talk about rotations. Which is going to turn a figure. So those are the 3 ways it's going to move. Then we'll have a quiz over this. That quiz will be next Friday. Okay, so when I'm gone, the last day that you have the sub, which will be Mrs. Brady. Similar, there is one type of similar transformation that we'll also talk about. That's called a dilation. But we'll talk more about that after we take our quiz over the 3 types of congruent transformations. All right, so a translation slides a figure along a line. It does not turn. Every point of that figure moves the same distance and the same direction. So here's an example of what a translation looks like. If I have a triangle right up there in quadrant 2, that's the original triangle, because I can tell by the way the arrows are pointing. And if I slide that figure, I'm sliding each point the same direction and the same distance, and it creates a new triangle, same shape, same size, they're congruent, but it's located in a different spot on the coordinate plane. And that's what a translation does. Translate means to slide or to move around. Okay. I guess you could think like translate when you're talking about a different language. It should have the same meaning, but with different words, right? So I want you to tell me whether the blue figure,
That does not always work though.
Well, you're right. Some
Like,
translations don't.
have words that are like similar, because I know specifically translating Japanese and Greek and English are difficult.
Different origin groups, like a lot of the languages that we speak are Latin based, but Japanese is not. You're right. So there are some words that don't translate. So tell whether the blue figure is a translation of the red figure. So the blue figure, we would call that the image, which is another way of saying the new one. So the red shape is the original, the blue shape is the image. So from going from this red trapezoid to the blue trapezoid, would that be a translation? Yeah, they just moved it, right? So that is a translation, which I'm going to abbreviate that. Okay. For example B, starting with the red rectangle, did they just slide the rectangle over? No. What did they do with it? What would that be called, Xander? Yeah, this one actually would be a rotation. Yeah, that would be a rotation for that one. So it's not a translation. So, obviously the questions on your homework tonight are going to say, yes, it's a translation, and no, it's not. This one's no, it would actually be a rotation. What about example C? Is that a translation? Did they just move it over? No, they changed its size, didn't they? And so actually, this would be called a similar transformation. So that would be a dilation. A dilation is going to change an object's size. Congruent shapes are the same shape and same size, but similar shapes are different sizes. So this would not be a translation. It would be a dilation. What about example D? Is that a translation, Lucy? That one's also not. That's a reflection. You're correct. This would be a reflection over this imaginary line that I'm going to draw right there. Should be more closer to the middle. You're right there. Right. What about example E? Is that a translation? Yes. Yes, it is. So a translation should result in the figure being the same direction. Everything looks exactly the same. It hasn't been rotated, hasn't turned, hasn't been flipped. Okay, so it looks exactly the same, just in a different spot. It's literally been slid across this line, and that line is going to be the same for all 3 points of that triangle. Now it looks like a triangular prism. Okay, so one of the things you're going to have to do in your homework, there are 2 questions on tonight's homework. I want to say it's number 10 and 11. If you read the note on tonight's 2.2 homework, you'll know exactly which 2. But there's 2 questions where it's going to ask you to use arrow notation. No, well, it's not going to ask you to use it. I'm asking you to use it. Because if you want a good grade on your quiz next Friday, you're going to have to understand arrow notation. But what arrow notation is it tells you what's actually happening to the coordinates. So we said that the shape's being slid around, but what's actually happening? Well, if you slide a shape to the right, what you're doing is you're going to add to the x coordinate, because remember the x coordinate, x-axis is the left-right axis. So if you add to that x coordinate, it slides it to the right. If you subtract from the x coordinate, it's going to slide it the negative direction to the left. If you see a shape that has moved up, that means they added to the y coordinate. And if it moves down, they subtracted from the y coordinate. Okay, does that make sense? Okay, this is of the 4 different transformations we're going to talk about, the translations are the easiest of the 4. So this says translate triangle MNP, 3 units left and 4 units up. 3 units left, 4 units up. Let's start with M. 3 units left, puts us over here. 4 units up, puts us up here. So that's going to be our new M coordinate. Oops, I went over too far, didn't I? Should just be right there. So 1, 2, 3 units left, 1, 2, 3, 4 units up. And so that point is now going to be called M prime. The points of the new shape that we call the image are called prime coordinates. And so you put an apostrophe next to the letter. That way we know which one the original one is, and we know which one the image is. We're also going to move in 3 spots to the left and 4 spots up. And that's going to put it right here. We'll call that N prime. And then P, move 3 units to the left, 4 units up. Puts it right there at -2, 1. And we'll call that P prime. And then go ahead and draw, or connect, I should say, your points. And it should give you the same exact triangle in a different location on the coordinate plane. So the new points of the image, M, N, and P, are called prime. Not because they only have 2 factors. That's what prime numbers mean. But prime because they're the image. Now, if I were to move it again, and 2 transformations have happened, and we're going to see that later this chapter, we would use double prime to show that it's the second transformation. So you put 2 apostrophes next to it. Any questions so far? Yes. Oh, Good question. I guess you would look like a quotation mark. They're not actually going to have you type it in on big ideas. They'll have it typed and they'll say, what are the coordinates of the double prime image? And so you just have the coordinates on, like 3, -2. Okay, that's a good question. You probably would use apostrophe. Okay, so when you get to number 10 and number 11, let me double check real quick, make sure that's the right one. Has anyone started their homework yet tonight for this? Is it 10 and 11? Do you remember before you're nodding? It's okay. So if I click on the note, which you guys should be checking the notes for these. My note doesn't show up. I have to actually click and edit it. I think it was 10 and 11. Nope, that would be 2.1. I'm clicking on the wrong one. How about 2.2? Yes, 10 and 11. Okay. And then tomorrow will be a couple different problems. And I'm going to have you practice using arrow notation a few times on each of these homework assignments. So what do I mean by arrow notation? Well, for M and N, we can see for M, N, and P that the 3 different locations. So they have 3 different coordinates now. And so what I'm going to do is I'm going to start by writing what the original coordinates are of M, N, and P. So I basically wrote down 2, 3, which is the coordinate of the original M point. 4, -1 is the coordinate of the N point. And 1, -3 is the coordinate of the P point. And so I've got those written down. And I'm going to draw arrows showing that these 3 new points are going to be different. And above the top arrow right here, I'm going to write what's actually going on. So if I move it 3 spots to the left, what am I doing to the coordinates? If I move 3 spots to the left, from the X, exactly. So if it's moving left 3, I'm going to write X -3. It also moved up 4. So what's happening to the Y coordinate? Lucy? Exactly. So I'm going to put a comma to separate, just like we do commas between X's and Y's, Y +4. I'm only going to require that you write that on the top arrow, because this is now going to be applied to every single one of the points. So if we subtract 3 from the 2 coordinate here that we have, what's 2 - 3? Sky? -1. The M prime X coordinate is going to be -1. What's 4 - 3? Anyone can answer this. What's 4 - 3? Everybody? 1. And what's 1 - 3? -2. Okay. All right. So now I'm going to go and change the new Y coordinates by adding 4 to the Y coordinate. What's 3 + 4? 7. What's -1 + 4? 3. What's -3 + 4? 1. Now, if I did it correctly, the 3 coordinates that I have here are going to match the same 3 that I just plotted a moment ago. So M prime, -1, 7, that checks out. N prime is 1, 3, that checks out. And P prime, -2, 1, that one also checks out. So when they ask you for the coordinates of a point, you don't actually have to graph it to be able to tell. You can just use arrow notation. And sometimes they ask you that. Sometimes they don't even give you a graph, and they'll just ask you, what's the X coordinate going to be? Next week, you're going to do an IXL where they do a lot of that. They're going to say, what's the X coordinate of the P double prime? And so you'll have to use arrow notation so you can tell. So that's what it means to use arrow notation. It's just a fancy way of actually showing you exactly what's going on with this transformation. The vertices of a square are, well, there. I'm not going to read all those. We'll say those are them. It says use arrow notation to find the coordinates of the image after a translation of 4 units right and 6 units down. Oh, and if I translate it 4 units right, does that affect the X or the Y coordinate? The X coordinate, you're right, because that goes left to right. And if I am sliding it 4 units to the right, is that going to add or subtract to it? It's going to add. So we're going to put X +4 on the top of this arrow. And then we're also going to slide it 6 units down. Martin, if I go 6 units down, what does that do to the y coordinate? That's right. So notice I don't have a graph. I just want to know what the new coordinates are going to be. I don't have to graph them to know what the new coordinates are going to be. I just have to add or subtract. Garrett, what do you get for -1 + 4? Okay, and what about 2 - 6? Okay. Carter, what about -3 + 4?
1.
And 2 - 6? -4. Okay. Lizzie, what about -3 + 4? Yeah, Carter just said that one. And 4 - 6? -2. Okay. And Brady, what about -1 + 4? 3, and then 4 - 6. -2. Yeah, and so you'll notice you see a lot of the coordinates that are the same. Like I see 2, 1 x coordinates, I see 2, 3 x coordinates, 2, -4, 2. That's because it's a square, right? So if it's a square, you're going to have 2 points that are right above each other on both sides, and then 2 that are horizontal from each other. Okay, so notice I only had to write it on the top arrow, right? Just x minus or x + 4, y - 6, just have to write on that top arrow. If you want to write on each one, you could, but you don't need to. Okay, so we're almost done here. It says describe the translation from the original coordinates to the image. So if they add 1 to the x coordinate, Vegan, what direction is that going to move it? How many? 1, okay. So I'm going to say right 1. And then Carson, if they subtract 5 from the y coordinate, what's that going to do to the shape? When it says y - 5, what direction does that move it? Down. Okay, so down how many? Down 5. There we go. All right. Dawson, what if they subtract 7 from the x coordinate? What's that going to do? Okay. And what does it mean if it just says y?
Do nothing.
Do nothing. That's right. Yeah, it doesn't move up or down. The image just moved left and that was it. Or left is this way for you guys. All right, just moved left and that's it. It didn't move up or down. Okay. What about here? What direction did the shape end up moving? Did it move left or right here? Sky, what do you think? Left, how many? Right? Yep, they obviously subtracted 3 from 6. Okay, so it moved left 3. And if it went from -2 to 0, what direction did it move and by how much, Shane? Up 2. Nice job. What about the next one? X coordinate goes from 10 to -14. What direction and by how much did it move, Carter?
Left 24.
Left 24. That's a lot. It's a big move. That's right. And then what if it goes from -5 to -14? Xander?
Down 9.
Down 9? Down 19? Sure. To go from -5 to -14? What? It's just 9, isn't it? Yep, just subtract 14 and 5. Yep, so it moved down 9. Okay. And then our last question here says, describe the translation of the red figure. You'll find out that they use the red color to represent the original shape a lot here. And then the blue one always represents the new one that we call the image. So the blue figure is the image. I'm going to write that because even though they didn't say it that way, they're going to ask you that later. They're going to ask you specifically which one the image is. So it's a translation, obviously, it moved. So instead, basically what we're looking at is instead of them telling you what the coordinates are, they're plotting them for us and we have to figure out what that is. So what we do is we're going to look at one set of points. For example, we could look at this one here and that point corresponds to this point right there. Whatever that point moved, all of them had to move the exact same. So let's start with the x coordinate. If you start with the red shape, is the blue shape to the left or to the right? You're awfully quiet for an easy question. Did it move left or right, Owen? It moved right. And how many right did it move? To go from -2 to 4, it moved right 6. You're correct. Julia, did the point move up or down? Okay, and how many down did it move? Down 3. That's correct. Again, look at the y coordinate. The y coordinate was 3. Now the y coordinate is 0. And so it moved down 3. So you're doing the same thing there that we just did up here. It's just we have to actually look. Now, if you want to double check your answer, try checking a second set of points. Right 6, down 3. They should all move the exact same. If one of the points moved differently, that would stretch the shape, which would change its shape, and it would no longer be congruent. So because it's congruent, they all have to move the same direction and the same number of movements. Okay. Questions on that? All right, I think that's it for our notes. Go ahead and get started on the homework.